guys, I'm back again. So we covered a few things already, which is some of the basic things like introduction, also the request idle callback, difference between React Stack, React Fiber, and in the previous one I did the little to-do app, which will be our guide for the rest of the video series. And before I get into the deep stuff, I just wanna go through a few principles of React, or at least how I see it. And as I said before, it's inevitable, I think, that we touch some of the things of declarative style and functional programming because they are quite tied to React and how it works. So the principles of React, it's a pretty old video in terms of like in the JavaScript world. I think it's 2013 or 14, maybe 14. So Pete Hunt is or was a core contributor. I'm the member of the React team, and he was comparing JavaScript frameworks together. And basically every JavaScript framework's main responsibility is to manage DOM manipulation in some way. And there was that quote which I really liked, that he would like to think that React is the least leaky abstraction over the DOM manipulation. And I think that's nothing more to it. It's just React is a really good abstraction over it. And the reason why is that because of its declarative style, which makes it easy to follow logic, and because of this style, it scales well. It's even easy to create applications that are far larger and complicated than just simple to do because of how React exposes its API. So that's definitely one thing. I will get into more detail. Just give me a few minutes. Also, there is a interesting talk by Jordan Walk. I think that was the really first video out there where they introduced React to the world. The link is here if you wanna watch it. I will make it available, this little markdown file later on. And that's what they say in the React GitHub page. So what is React.js? It's declarative, efficient, and flexible JavaScript library for building user interfaces. So building user interfaces is pretty self-explanatory. So basically it says that it's meant to be used on the front end to create interfaces, not on the back end. Primarily, it's a JavaScript library, flexible, efficient, and declarative. I think the main point here is being declarative. And that's what I wanna show a few examples what it means to be, because I think sometimes it might be confusing what's the difference between being imperative and declarative. So I just wanna give a few examples, just plain JavaScript stuff, and React stuff. And also I'd like to show one way how I would like to think about the bridge between React API and the implementation, and why I think that it's one of the core functional programming principles that we can see there. So, and yeah, these are the things that not now, but back maybe 1.5 years ago, 2 years ago, when I started reading things about React, that I read blog posts about developers and dudes who just, for example, got into an interview and they were asked what is React, compare different JavaScript frameworks, and like these are the main points that they come up as either to describe React or just these are the things that considered to be pros when you choose React. And almost every time, I think that's not the case, but that previously the one of the main factor was virtual DOM. and everyone was about, oh, it has a virtual DOM, and how so cool is that? It's fast, and mainly the I think it has to do with Angular 1 being that slow, and everyone was just rejoicing that how fast was React with virtual DOM. But I think that absolutely not the thing that made React popular, and why React is good. It has much more to do with other things, but let's just go through. So definitely virtual DOM in itself is a good thing. Speed, yeah, good thing. JSX, I think personally, it's really good abstraction. Basically JSX is just JavaScript, nothing more. It gets compiled to JavaScript with Babel. So the thing that you can finally get rid of HTML and just write JavaScript whole application with that, and express everything with JavaScript is a fantastic thing. I mean, it just improves your JavaScript knowledge, and yeah, that's the huge advantage. Unilateral data flow, when you think about the two-way binding of Angular, it's a blast. But I think that the main two things that made React popular is definitely its declarative style, and that it's component based. So component based is basically we can later, it's not a one-to-one mapping obviously, but later it can be translated as individual functions can be composed of each other. And declarative means that well, we see what declarative means, at least what I like to think about declarative API. Okay, so I definitely think that the last two are the main contributors that made React so popular. Okay, and as I said, it's inevitable to get into functional programming. So it was Jordan Walk who said that, like, immutability, declarative API were the first thing that like the very basics that React is built upon. And it's so true that as now we have Reason React with OCaml. Initially Reason was prototyped with another ML language, but because of the types and maybe they did not have that many resources, and functional programming wasn't that widespread. I mean, just think about it. If you know the dude who, it's I don't know, I'm not sure of the real name of the dude, Brian Lonsdorf. It's Dr. Boolean. He's a pretty damn good guy in the JavaScript community. So he had a conference talk, I think it was 2013 or 12, when he was, well, not kind of, but he was complaining about that Lodash is not the way how helper libraries should be built, because it basically prevents function composition, which is one of the most powerful feature that can be done with JavaScript, that it has a lexical scope. It has first class functions, so basically you can go and do functional patterns, but with Lodash you can't do that. And just think about it, that was the year 2013 when React was released. So a lot of things changed since then. We have Redux, we have Runda, we have Sanctuary, and yeah, so a lot of changed. So now it was the right time to get Reason to actually to get React to Reason. But nevertheless, the same thing applies that React was built upon, like at least immutability and being a declarative API. And also, yeah, it's a bit far-fetched maybe, because we have components as classes, if you think about, and also functional components, a lot of things happening under the hood. But from the perspective of the APIs, for example, if you have a functional component that's not using hooks, then you basically have a pure function which its output is based purely on its inputs. So if components are basically functions, then components can be composed just like functions, and it's I think a lot of time you do that, especially like how functional children and render props became more and more popular. That's basically can be traced back to the same patterns, and yeah, so that's one thing. And also like declarative, I know I said a lot of time declarative API. I just want to make one thing clear, that what they are exposing as an API style, it's definitely not the implementation style. So just think about that. Like, I'm pretty sure that everyone familiar with the map, filter, reduce functions that are on from, I think, ES6. They are on the array prototype. So they're absolutely based on imperative for loops, right? So under the hood they are basically for loops. So the implementation style is definitely imperative, but the API that they are exposing is declarative. So the whole idea is that you just don't have to know a thing about how they are working, and that's basically the way with React as well. So, I mean, it might be self-explanatory. I just wanted to make it clear that no matter that what you use and what they expose as an API, the React core team, the underlying implementation is a very C-like code, as we will see. That it's not even object-oriented fiber. It's like a C code, like procedural with structs. At least I think, and it's not just my opinion. Actually, in some podcast, the core team said that it's very much a C-like code. So yeah, but that's like fine, right? So the only thing that matters is what they expose to the end users, which in that case are the front-end engineers and developers and programmers who are gonna use React to build real-world stuff. So let's get into some code, and this is gonna be like mostly about this declarative style and why I think it's good, what it means in my opinion, and how I would like to think about the abstraction that React provides. And I promise that this is gonna be the last thing, which is kind of abstract ideas, and then we're gonna get into real programming. So that's another Create React app what I have here. The only thing I've done before is I installed React Router DOM. So what I want to do is first show you an example of imperative and declarative in React Router than in like in a normal JavaScript environment, and then probably in React as well. So to get started, probably I wanna set up the router. So I just need to import a browser router. I think it's in from React. I mean, I think I installed React router, then Splendid. So I've got browser router. Browser router is basically a normal router. It just incorporates the history object. You don't have to create it and pass it as done as a prop. So it's basically the same thing. It's just a bit more convenient to use. And I wanna render only one route, so I can use the switch from the same package. So if you're not familiar, I think you're familiar with React Router DOM, but if you're not familiar with it, it's just basically a big controlled if statement based on the history API. Oh, right. Sorry, so I want to have a route here, and I need to import the route. Okay, and I will have a path first, and we have a path of second. I don't think it will make a difference, but I wanna have the exact prop on both of them just to be in case, which means that they will only get rendered if the whole route matches the path. And as for the component, I will have a const first, props first, and I will have a second. Second. So component is equal first and component equals second. Okay, so second. Oops. Sorry, but what the heck am I doing? Okay, so okay, now it's working. Sweet. So I also wanna create stuff which gets rendered every time. So so all equals props return all. Just wanna console log the props out. Okay, so the props is empty, which is not that good. I think it's because we have to wrap it in a route to have the router props, or wrap it with in the with router higher order component. I just wanna go with the easiest way, which is all and path. I think we can clear the path, so it's gonna be rendered no matter what. Okay. Yeah, okay, so we have the props here. Okay. I can probably render a button here. So it's gonna be a silly example, I think. Maybe not that silly, we'll see soon enough. Okay. I want to put it into a div, so since it's not an inline thingy, yeah, it puts them in a new. Okay, so redirect. You might know what I want to do. Anyways, okay. So yeah, that's gonna be the first, well, probably the easiest example of imperative versus declarative. So what I can do is, so let's assume that you wanna redirect to second. Redirect to second. Okay, or just simply, well, if you want to redirect to, yeah, just to make it even more like realistic, just bear with me for a sec, it will make sense, I promise. Okay. Okay, so imagine in this scenario that you have this app. It's a pretty good app where you need to log in, and by default, this auth thingy indicates that you are not logged in. But let's assume that if you are logged in, then you will be automatically redirected to, for example, the second page, because we are on the first one. It doesn't really matter, it's a silly example, but you will automatically be redirected. So how can you achieve it? So there is one way of achieving it, and so yeah, one way of achieving it is so if you, let's assume that login, if you just click on it, that's you logged in. So what you can do is you can use the history API, which is like a browser stuff, and React Router DOM is encapsulating all of it, and it provides you via props. So that's why I go and log it out. So if you go to location or history, and you have push, which is it pushes a new route onto the stack, and basically it triggers a navigation. So you can do this.props.history.push, and you can create a new route to second, like second is that's what we said, that this is the authenticated route. And also you can you want to make sure that this state set state auth is true, right? So that's one way to do it. So I'm on the first, I click on login, and I'm on the second, right? So it works flawlessly. But yeah, there's another problem that by default, even if the auth is true and this component gets re-rendered, the routing not gonna happen, because the click handler not gonna get invoked. So we need to do another thing, like it, which is a component did mount, to make sure that component did mount if this dot state dot auth, then we need to basically do the same thing, right? But it's all right? So we can do this. So that's one way to do it. So as you might have guessed, or you might know, and I'm just repeating myself, that's the imperative way of doing things. Like you're telling how to do things, you're describing the solution. Whereas so you're creating the implementation detail. So you can say that basically imperative write a detailed solution, not write the how. That's the main thing, the how. Imperative write the how. Whereas the other thing is we can say don't solve the problem, but rather write a solution, which is, you can translate this to what needs to be done. And that's what I said, because your first question might be, okay dude, yeah, that's pretty good, like don't write down the how, but at some point you need to write down the how, right? And that's absolutely true. At some point you need to, but this thing can be encapsulated in such a way that you don't have to deal with the boilerplate things, but you can have small pieces of what's, and the what can be combined to solve a larger piece of problem, and that's basically declarative style. So let's see and let's rewrite this class into declarative solution. And trick out of 4, which we are using here, is basically provides this out of the box. So how can you solve this problem? So you can do something like, you can get rid of the props history push. You just need to set the state to auth. You don't need component did mount. All you need to do is if this dot state dot auth, then return another stuff called redirect to, and it's gonna be second. So let's go to the first, right? Because that was the initial assumption. So when you log in, you go to the second. Yeah, that's my bad, but eventually, I mean, that's pretty much the same thing. So you don't need to deal with how things are implemented. So you don't need to know what this redirect does under the hood. It does the same thing as just we did here, but you don't necessarily need to be aware of these things. All you need to do is just, so the main point is what needs to be done. So what needs to be done, it needs to be a redirection here. All the implementation details are in the response, is the responsibility of the library. So that's how you can differentiate between declarative style and the imperative one. Also, another thing that is not React related but simply JavaScript related is the classic map and filter. So like if you wanna iterate through something, so let's get rid of this, and let's say that we have a const array which have like 3 numbers. So what I can do is I can be imperative. So if you tell me that you want divs to be in the DOM with the inner HTML to be these numbers, then I can go ahead and do something like let elements equals an array, and I can go ahead and write let I to be 0, I smaller than r dot length and I plus plus, and then what I can do is elements at the given index r equals react create element, and you said you wanted a div with props nothing, and children react node of children. I think if I just put it, I'm not sure how create element works in this context. Can I just Can I just put array at given index? I'm not sure if I can do that. Let's just give it a go. So can I just put like elements? Yeah, okay, so it worked. I'm just missing the key. Okay, but it's alright. So yeah, that's how the inner HTML is there. You need to put it as a child. Yeah, okay, so it worked. So that's one way to do it, right? That's an imperative way of that. I'm telling how to do things. All these steps are described by me. So you have the array, you create your for loop, you're assigning a new element, and you creating your own React element with the type, the props, and the child. But I mean, 0% of people are doing this for a reason, right? Why would you do that when what can be done is simply like, you know what I'm going to do, item div and item, and it's gonna result just in the same DOM structure. So I think that you can see how easier and more readable these things are. That's another thing to take into consideration in regards to what declarative and imperative means. And also, so one of the things that before I'm transitioning into the third thing of how I like to think React works is just think about it, how more scalable this array.map with the JSX is compared to this solution. Just imagine that your React application is bloated with this kind of code. So readability, also just think about that. You can map here, you can use function composition for another map, a filter, or basically just anything. Whereas here you need to really be careful of what you're doing, because the probability for an error is much higher than which is simply a declarative style. Okay, and the other thing I like to talk about is something that is in the boundaries of not a complicated subject, but it's like encapsulation of side effects, basically. If you heard about wrappers, algebraic data types, and monads in functional programming, I think that it's not exactly what React does, I think, but it can be considered of some sort. So what I'm thinking about is I don't even know how to get into this. So let's delete these things. Let's delete everything that we don't need. Redirect. Okay. So assume a scenario where you have something like next route, okay, and this is obviously a string. It can be a lot of things. Like, let's assume that this can be like 5 different things, and you have a function to handle a route change, which will take it won't take anything because it will read from the state, and you wanna call this handle route change. So what you want to do is what you will end up with is a switch statement. For example, this dot next route. Okay, and like you will have case 1, for example, and you will have something here like call this dot props dot history, as we did earlier, right? So that's the imperative way of history dot push changing routes. And after you will have a break, and you will have a default case and just simple break. Okay. So imagine that you have these things. Case 2. Okay, just for simplicity, let's leave it that way. So again, I don't want to get into much of functional programming, but basically if you're not returning anything from a function, that can be considered potentially as a side effect, right? So function, from a functional programming point of view, is always a self-encapsulated calculation of some sort. So you put inputs into the function and you get a value out of function, and if the inputs are precisely the same, the outputs will be precisely the same, and the function internally doesn't change any outside variable, that doesn't cause any changes to the outside world. So the problem is that no matter what, we need to communicate with the outside world, and changing routes is definitely communicating with the outside world, and it's called side effects, right? So it doesn't have any return value when you call this thing. It just simply produces a value, and a lot of things are there, right? So like route changes, writing to the console, communicating with any API, let it be XML, JSON, GraphQL, name it, whatever you want to do, database, connection, query, that's not how you spell it, DOM, query, DOM mutation, so a lot of things are side effects, which is, as I said, it's not a problem. You need these, but it's definitely the part of the program where things can get messy, right? Because you definitely will have less control over what's gonna happen, and but that's basically it. So this is a route change, and so what if you wanna test these things? You simply, the only way to test what happens here, it's either you check the whatever mock you use as a history, so you check that after the function was called, the history object which you mocked changes appropriately. So that's one way of thinking. The other way of thinking is stubbing the push method, and you check whether it has been called with the right arguments. So these are your only ways of testing things, but in isolation it cannot be tested because it doesn't return anything. So it's not a so it's not a pure function. I don't want to complicate it any further. And pretty much, if you think about, so that's a route change. But if you think about back in the days with, not back in the days even, but the video before that, we were talking about the request idle callback. And if you remember, I was querying DOM elements with the native DOM API, but this is the same thing with jQuery. So back in the days, what you did is you directly communicated with the DOM API. So that's the same thing as changing routes. So you are firing a side effect because it doesn't return a thing, for example, or even if it returns something that it's doesn't purely rely on the inputs. But just think about that, if you were referring to the document element, if you're not in a DOM environment, it will just simply fail. Just think about it, that if you run in your code in a Node.js environment, it will fail miserably. So there are all these things which makes it harder to reason about your code. So what can be done, right? So that's definitely not a thing that we have to avoid, because otherwise, so you can't avoid DOM mutations, and neither you should. It's just how can you tame these side effects? And one way of doing this is simply wrapping this side effect in a way that you just describe what needs to happen later on, and you're delegating the responsibility of actually calling it to some other part of the program, or to some other part of the program that the developer is not even conscious about. So let me walk you through what I'm thinking about. So what if, just imagine this handle route change, it handles the actual calling of the component, actual calling of the function, like the push function. So what if, instead of simply calling this, I'm not calling it with break, but I'm simply returning a function. So what happens is, when I call the handle route change, nothing is gonna happen. It will just return a function. So what is the advantage of that? First thing is we are getting something from the function, so it's not gonna return undefined, in other words void or unit, or name it whatever you like to. But even if I push this like here next route, I can change the signature a tiny bit. So this handle route change, and I'm gonna call it with this state.next route. So just watch what happened. So we did not have any arguments, and we did not have any return statement. Now we have an argument, and now we have a return statement. And if you think about it, now the return statement is gonna be exactly the same every time, depending on what we're gonna produce, and no side effect will be created. So what we just did with this little trick is made it a pure function. It's referentially transparent. So now when you want to test this, you don't have to mock it. The way you test it is you put in a route and you check the return statement. So the return statement will be stable across multiple calls. It's gonna be a one-to-one mapping. Okay, now you might ask, but dude, what's the point? You just delegated the inevitable, because in the return statement we will have to call this anyway, right? So okay, this is now not an execution but a function, but now what you have to do is call it again. So at this point we will produce a side effect, which is absolutely right. Like your argument is valid, like we're just delaying the inevitable, sort of. But by doing this, you're pushing the boundaries of where your code is pure and can easily be maintained, or it can be maintained more easily, it can scale better, to the point where your code communicates with some other part of either your program. So here our program communicates with the history API, but what we did is we pushed the boundaries to a point where we have most of our code written in a pure manner. If you so if I wanna be a bit tricky, I can do something like I can return. So I can do something like I can return an object and do something like this. And if you have read something about monads before, that's not exactly, but kind of what they're doing. So this way you can call run on it, and that's what gonna execute the thingy. So yeah, that's definitely one thing to make your code a bit more pure and declarative. But how does it connect with React, you might ask? Because it might work with the history API. It also, I think it's pretty easy to make a parallel between the history API and data fetching, right? Because you can delay the actual data fetching to the point where you cannot delay it any further. But what about other side effects like DOM mutations? So what if I say here that, okay, if that's done, then the document, okay, that's you don't want to call document basically. You don't really want to do anything in document inside React unless you have a really strong reason to do so. So it's kind of an anti-pattern. I just do it for the sake of argument here. So but if you want to do append child to some arbitrary DOM element, doesn't really matter, right? So just imagine that G is a valid DOM element. So just imagine that that's valid, okay? I don't want to dig into obtaining and the references from React. So that's exactly the same thing, because from the perspective of our application, that's just a side effect as calling this.props.history. So the thing I want to make clear is that what we used to do with jQuery and the native DOM API is exactly the same thing. So we directly called these jQuery functions which modify the DOM structure. Now, let's think about what React does. In React, what you do, and yeah, I know that there are a lot of life cycles and stuff, but just let's stick with render. What you do is you define the structure of your application, right? And in every render, you're returning something. No matter what, you need to return something. And that's one thing, right? So you're returning something. That's a good sign. It's not a side effect. So you're returning something, and you can obviously have internal state, but just let's stick to you're returning something, and that something is like mostly determined by props. So it's if you want to go that branch, return this. If you want to go that branch, return that React element 3. But the important thing here is React elements are basically just objects, right? And from the perspective of the developer, no effect had been done, right? So no DOM mutation had been fired. You're just writing functions that are returning React elements, and if you want to test them, all you need to do is just you need to compare these objects, and if the objects are equal, then you will end up with the same DOM structure. If you think about it, and you have used shallow rendering in Airbnb's enzyme, that's the thing that it leverages. So the actual reason that shallow rendering and shallow testing works is because it doesn't require a DOM implementation. It doesn't get to a point to where it does anything with it. It just does what we had here. So just imagine that if you had the shallow rendering, it compares that this handle route change returns this function which we'll call document append shell. It's not going to get called, it's just return the signature if it's equal, that it's considered to be the equal outcome. And that is exactly what React does, and I think that's where its power lies. That you as a developer are not doing anything. You are returning the same objects based on the same inputs. And that's the basic principle. Obviously, it will get complicated with internal state and life cycles, but that's the basic promise, that you are returning the same objects as React elements, and the actual call to the native DOM API is delayed to a point where the developer has no control over it. So the developer's responsibility ends with returning React elements. So the developer will actually not gonna call anything on the native DOM API. So the React team made an API where the actual call gets delayed to a point where it's not executing it. It's not the responsibility of the developer. So I don't know if it makes any sense, but that's how I would like to think about React. That in regard to the native DOM API and the jQuery and the why it's declarative, you're not actually telling React how to mount a div element. You're just telling that a div element needs to be mounted, and React will take care of it because the implementation details are pushed beyond the responsibility of the developer. So I hope it makes sense how I would like to think about what React does and where its power lies, and why I think that's probably the most popular. That's the reason why it's so popular, because you only have to deal with what needs to be rendered. It scales incredibly well. Okay, so that's it. It almost took an hour to get through this, and now that we know these things, I will in the next video start creating the boilerplate for the actual Fiber project. Alright, so thanks for listening. That's all for today, and see you later, dudes.